Hello. In this video, I'd like to go over the first two problems from the Jiuzhang Suanshu, or 9 chapters on the art of mathematics, sometimes translated as the 9 chapters on the mathematical arts. So the book is called the 9 chapter mathematical arts because there are 9 chapters and it's concerning Suanshu, which meant arithmetic in today's Chinese, modern Chinese, but it actually meant mathematics in general in China. The first chapter is called Fang Tian, or rectangular fields. And this chapter concerns arithmetic operations like multiplication, division, and also the arithmetic of fractions like addition, subtraction, multiplication, division, with applications in surveying, as in to determine the areas of rectangular shaped fields and fields of other shapes. So we'll first understand the context of this math text written around 2,000 years ago based off of reading the original text, because you can't really understand ancient Chinese mathematics without understanding ancient Chinese. So we begin with the first problem here. It reads, 今有田广15步中16步问为田几何答曰一亩 So to understand what it's asking here, let's begin with the first two words, the first two Chinese characters, 今有. So in Chinese, you would directly translate this as now, or today, or now given, or now there is. But in the math tradition, the mathematics tradition of ancient China, all problems beginning with 今有 is actually more of a hypothetical. So they're asking, suppose there are. So it's better to translate this as suppose there are or suppose there is. Okay, and we'll take a look at the next character here, tian. Well, tian actually means a field, and here it doesn't seem to be very specific which shape this field is, but the first two problems is concerning rectangular fields. So we assume that they're rectangular. Okay, so this is rectangular. All right, so we'll take a look at the next character here. This character is guang. So guang actually means the length or the width, depending on which orientation you're talking about. But that's true in English. In Chinese, guang is used for the horizontal length, and zhong, or also pronounced zhong, there's two possible pronunciations. That means the vertical length. Okay, so after they tell you what the guang and zhong are, right, the two directions, they'll tell you the length of these. So here it says 15, which means 15, and 16 for zhong. Okay, so that's the 16. So we usually translate this as the width being 15, bu, which is a pace, around 1.5 meters in width in today's measurements. And 16, so that's 16 bu, so 16 paces. So maybe we should actually write paces because it's in English we have to make this plural. Okay, so that's the information given about this rectangular field. So the width is 15 and the length, or maybe the height, is 16. Okay, and the question, 问, that means question. So I'm going to underline this. This is how they always begin the question. They start with the word question, 为田几何. So that translates to what is the size of the rectangular field, or how big the field is. Okay, and when you see Chinese math problems, they always start with a description of whatever needs to be solved, the question, and the answer. And the answer is called 答. So 答曰, that means answer is. 一亩. Okay, so what is this? So 一 means one in Chinese. 亩 is actually a unit of area used mainly for measuring fields, how big fields are, and that's roughly 240 bu squared. So in ancient China, what's interesting is they have one-word characters for units of area, and I'll later go into what's the bu squared in Chinese later in 1.02. So that's just a quick look into the Chinese mathematical language used at least 2,000 years ago. We have under more texts that dates around that time that also use very similar language. So we'll take a look at the second problem. Second problem says 又有田广十二步，中十四步，问为田几何？答曰168步。So what does it say? Okay, so the first character is a bit different. First character does not say 今有, it says 又有. So 又 just means again or there is another. So this is best translated as suppose there is another rectangular field. And we assume that's rectangular for this particular problem. Its width, 广, is 12, so 12 步, 12 paces. That's its width. 中14步, so that is the height or the length being 14 paces. 问 question. 为田几何? So how big is this field? 答曰 answer is 168步, so 168 步. So what's interesting here is you'll notice that this unit, which was only a length unit, right? A length unit described in the question above, why is it using the same character for an area? Because when you multiply two lengths, you should get an area. So shouldn't this be like bu squared, whatever that is called in Chinese? Well, we would consider that's the square bu today in modern mathematics, but in ancient China, units are depending on the context. The unit actually depends on context. So in this case, this one character bu actually means square bu. And once we look at the solution method, which is also written in the text, you get to see another term called 积步, so the product bu. So let's move on to the text for the solution method. So most Chinese math texts, they always begin with a problem, question, followed by the answer. And at the very end of all the questions with similar solution methods, they explain in detail what you're supposed to do with these numbers. So this question is about rectangular fields, so they call it 方田术, which means the method of calculating the area of rectangular fields, and that translates to the rectangular field method. So it says 方田术曰广中步数相乘得积步以畝法240步除之即畝数百畝为一頃. Okay, so what does this mean? So the first two characters here we've seen before. 广中, all right, that means the width and the length, or the width and the height. But in Chinese, 广 just means the horizontal length, and the 中 being the vertical length. So 步数, that just means the number of bu, so the amount of bu. In the questions, for question 1 is 15 bu by 16 bu versus 12 bu by 14 bu. And once again, a bu means the pace, which is a Chinese unit of length, and it's roughly 1.5 meters. It varies depending on the dynasty. It varies between 1.4 to 1.6 meters. Okay, so we understand that. Let's take a look at 相乘. So 乘 means to multiply, but in ancient China, they like to call multiplication of two numbers, like regular multiplication, as 相乘, which literally translates to mutual multiplication. There are other forms of multiplication in ancient China, like 互乘, which is a very different operation. I can't describe it here. I need to describe that more in detail once we get to the arithmetic of fractions. Okay, so that's 相乘, that means mutual multiply, but that just means regular multiplication of two numbers. 得 means to get or obtain. Okay, so we get 得. 积步. Okay, so here they use the word 积, which means product bu. Okay, so 积步 means product bu, and that kind of gives us a idea that there was a distinction between bu and bu squared. It's just you need to add this character 积, which means product, in front of it to tell you that the unit bu is actually squared or cubed. So depending on context, bu can also mean the cubic bu, and 积步 meaning the cubic product. But of course, this is about area. These two problems are about area, so it's just area bu. Okay, or bu squared. All right, so 以畝法240步除之. So what that means is using the rule of the moves, the mu rule, which is the conversion factor for converting between the square bu, the product bu, into mu. You are trying to convert that by dividing dividing by 240. Okay, 240步. And once again, this bu actually means the product bu, because you have to divide the answer, the result from the multiplication by 240 square units of bu. Okay, so 计母数. Okay, so what does it say is you'll obtain the number in mu. So what is a mu? Mu is kind of like the acre in Chinese. It's not exactly 1 acre in size, but it's similar in concept to the acre. And in ancient China, there's another unit of area which will not be used in these two questions. It's actually used in question 3 and 4. Here they tell you that you can convert between mu and qǐng. So that's another unit of area. That's kind of like the hectare idea, like hectares in English. But it says that 100 mu becomes or is or it's equivalent to 一qǐng, so 1 qǐng. Okay, so maybe I should write the pinyin for some of these units. So bu is bu, fourth tone. Mu is second tone, mu. And qǐng is qing. I believe it's first tone. Okay, tone 1. All right, so some people pronounce it mo. I actually pronounce it mo when I speak in my family, but I think the standard pronunciation is mu in Mandarin. Okay, so once that is understood, let's just go over these translations again, starting with the questions. So I won't read them in Chinese again, but let's just translate this into English. So here it says, suppose there's a rectangular field of horizontal length, which is the width, 15 bu, 15 paces, and vertical length, or the length or height, being 16 bu. Okay, 16 paces. Question, how big is the field? And the next one is there's another rectangular field that is 12 bu by 14 bu. What is the size of that? What's the area? Okay, and the method is you just multiply the two numbers, the width with the length, so the horizontal length with the vertical length. You get the answer in product bu, which is the square bu squared. And then to convert that to acres, so the Chinese acre, mu, you divide by 240. And to convert from mu to qǐng, you just use 100. You just divide by 100. Okay. So once we understand the language, it's good to go over the Chinese method, the ancient Chinese method of calculation. So I'm going to erase what I wrote here. I'm going to erase the questions. And we'll take a look at how the ancient Chinese viewed these questions, these geometry problems. So let's just take a look at a diagram. Let's draw a diagram. So we draw the diagram of a rectangle. I'll make I think I should draw the vertical part a bit longer, so I'll redraw this more like that. And I'll just demonstrate with the first problem, because the second problem is easy to recreate once you know how it's done with the first problem. So I just drew a rectangular field, and the width, or the horizontal length, so that's guang. Okay, so I'm going to write 15 bu. Okay, and zhong, all right, that is 16. Okay, 16 bu. All right, so it looks like that. And the way Chinese mathematics had always worked since the very beginning of written Chinese is that numbers are expressed in base 10. So it's actually very similar to how we do math today and what people learn in elementary school. So the ancient Chinese way of looking at this is we're going to split these parts. So we get, 10 here, 5 here for 15. Oh, actually, no, I got it wrong. It should be this way. And 10 and 6 to make 16. Okay, so once we have these lots from the plot, written or drawn in, we can do the multiplications. So I'm going to just write the multiplications in red here. This is going to be 10 times 10. So that gives us an area of 100 in this corner. So the upper left. On the upper right, we're going to get 5 times 10. Okay, so we're going to get 50. I'm going to circle these. Here we're going to get 6 times 10. So that's going to be 60. And here, lastly, we're going to get 6 times 5 or 5 times 6. That'll give us 30. Okay, and then what we do next is we're going to add everything. So you're going to add 100 with 50 with 60 and 30, add them together. Like that. Now this is how we do it today. So add the columns, 0, 5, 6, 3. That's going to be 11 plus 3, so 14. 240. Okay, so you get 240 square paces. And then once you convert this to mu, right? So I'm going to write this as bu. When you convert to mu, you just divide by 240, because that's the rule for converting from square bu or qī bu, product bu, into mu. So you're going to get 1 times that, no remainder. So you get 1 mu. Okay, I'll write that here. Now, I'm writing this arithmetic instructions or operations in the modern method, using the modern method. So this is not how they used to do it in ancient China. Because in ancient China, for over 2,400 years, 2,000 to 2,400 years, they use something called counting rods. So what are counting rods? Counting rods are called 算筹 in Chinese. So I'm going to write them here. So 算筹. Okay, this is a hard character to write. I think I wrote it wrong. Okay, 算筹. So this is written traditional, so it's harder to write it. These are counting rods that were used to perform arithmetic calculations, as well as problems with linear algebra and even polynomials, solving polynomials. So it can get pretty advanced. The application of the counting rods can get pretty advanced. But here we're going to look at basic arithmetic. So the setup looks like this. I'm going to write the units 1, 10, and 100. And how it's going to work is that for the ones, hundreds, 10,000s, the orientation of these counting rods will be vertical. So we're going to put the number 15 here, and 15 is going to be written with 5 vertical rods in the ones. And okay, for the 10s, you're going to use the horizontal. So we're going to use horizontal. So horizontal rods, the horizontal orientation is used for the 10s, thousands, 100,000s, and so on and so forth. So that's what it's going to look like. Okay, and what's interesting is they don't write the 16 here with the 10s and the 1s. So in ancient China, they will put the 16 at the hundreds and the 10s, because I'll explain later what they do and why they put it there in the first place. So they're going to put 1 and 6 like that. And that will represent not 160, but actually 16. So it's kind of confusing. And where does the answer go? Well, the product and all the calculations that lead to the product will be written in the middle. So there's actually a proper naming scheme for these parts. Okay, so the top one is called the 上位, or top position. Middle is called 中位, middle position. And the bottom one here, that's the 下位. Okay, that's the lower position. And it's named very obviously, right? So upper position, lower position is where you place your two numbers to multiply, and the product and all the steps that go there will be placed in the 中位. Okay, so maybe I'll also write the Hindu Arabic numerals for this. So we're going to write, this is 15 and this is 16 for now. So we're going to multiply 15 times 16. And what you start first is not with the 5 and the 6. You see, in modern arithmetic, we like starting with the ones unit, what the units place value, so the ones place. But in ancient China, they start with the largest ones. So we're going to look at the 10s and the 10s, even though that's under the hundreds, that's actually representing the 10s. So we get 10 times 10, and it gives us the 100 that we get here. So I'm going to put that, I'm going to write it, yeah, I'm going to write it in black. So I'm going to write the 100 here, and since hundreds place is always vertically oriented, the rods are vertically oriented there, we're going to put a vertical rod there for 100. Okay, so that's going to be 100. And I will write 100 here in the Hindu Arabic numerals, the modern numerals we use today. So far with that. And then next step. Okay, so next step, I'm going to erase that, rewrite it. So, okay, so the next step is to do the 10 times the 6. So I'm going to circle these two. And that will give us 10 times 6. So that's 60. And I'm just going to put a 6 right here in the tens column. So now we update our product to 160, which is 100 plus 60. So from the geometric point of view, we completed this so far and this area. So we're making our way towards the entire rectangle. Now we're off to this part. So we're going to look at the 5 times the 10. But what's interesting is once you're done with this multiplication, because we've done the 10 times 10 and the 10 times 6, is common practice to remove that entirely and focus on the 5. So we're going to do 5 times the 10, okay? And what they do is they'll actually shift these two sets of rods 1 unit to the right for both of them. So now we put the 10s and the 6, the 10 and the 6 for the 16 in the right place. And that's just one thing they did to keep track of what's been completed. Okay, so now you're going to multiply the 5 with the 10. That'll give you 50. Now, if I have physical rods, I would actually just place the 5 here and then manipulate it. But I know that 160 plus 50 is 210. So I'm just going to write that down directly. So it looks like 210. 10th place is horizontal, so we put the horizontal bar there. Okay, so now we have 210. We're going to update that. 210. Now this looks very slow, but in ancient China, the arithmeticians, the mathematical experts, the calculators, the human computers, I'll call them human computers, they can manipulate these rods very quickly and accurately. So it's a very ingenious invention that has many applications later in the development of Chinese mathematics. Okay, so we're finished with that one. 210. And lastly, we need to add the 30 from the 6 times 5. So I'm just going to quickly erase these. Draw them back. So 1, 2, 3, 4, 5. We're actually finished with the 10 here, so that's gone. They'll just remove those rods. And we're going to focus our attention on 5 times 6. Okay, 5 times 6, that is 30. That will be added here. And when you add the 30, you put just 4 horizontal bars here to make 40. So our final answer is 40. 240. 240 is our final answer. And that makes us complete the entire rectangle. Rectangle. And once that is done, you just get rid of the numbers you multiply together. So we get 15 times 16 equals 240. So that's the result. Very simple. Okay. So remember, for the first problem, not only do they calculate the area in square bu, they also they also convert this to mu. Okay, so the unit for area, the Chinese acre. So what happens is you're going to keep it like this with the 240, get rid of the 15 and the 16. And what you do for division is you put the divisor in the lower position. That's called the xiawei. All right, so the dividend, which is in the zhongwei, is also 240. And for division, there's actually specific terms for divisor, dividend, and quotient. So the quotient actually goes up into the upper position, 上位, and that is called the zhāng. Zhāng means merchants or commerce or to consult, and it probably originated from the term to consult. 中位, okay, so that's the not the divisor, that's the dividend. And dividend in ancient China is called 十, which literally translates to the actuality. And then 下位, so that is the divisor, that's called 法. The 法 usually translates to the method, but here it means the divisor. Okay, so that's the specific ancient Chinese math terminology for these three characters, 商, 十, 法, for quotient, dividend, and divisor. And this one's easy because you just have 240 divided by 240. So all you do is you just put one rod, and it's going to be vertical here, and the answer is just going to be 1. So we're done. Hardly any division to do. Okay, so that's it. That's it for these two problems, for the first problem. And I will not demonstrate the second problem. It's very similar. Maybe you can try it yourself. So I will continue talking more about ancient Chinese mathematics and get to more problems from several Chinese texts, mainly from the 9 chapters on the mathematical art, 九章算术. All right, lesson's over. Have a great one.